Moving on to section 3.2 for Grandmaster. Question 1, solve for angle theta. So this is the angle I'm trying to determine, and all I know regarding this triangle at the top is that the opposite is 5.7. That's not enough information. I don't have the hypotenuse or the adjacent. I can't solve for theta just using this one piece here. I have to look to these other triangles below, and I'm actually going to go right to the bottom one because that has the most information, and that's where we need to start. Okay, this blue triangle, this is an angle of 14 degrees, and the opposite is 5. From that, we can use trigonometry to determine either this length here, which probably isn't going to be useful because we have to work our way up to the top. So I would argue it's more beneficial to actually determine the hypotenuse of this blue triangle, because then that will allow us to work up to the middle triangle and then to the top triangle. So let's solve for x. So if we have theta, the opposite is 5, and the hypotenuse is unknown, opposite and hypotenuse requires the sine ratio. So that means the sine of 14 degrees is equal to 5 divided by x. Okay. Now I'm just going to apply a simple shortcut just to skip all of the steps in the algebra. So to get x, we just take 5 and divide that by sine 14. Okay, and that is going to work out to be 5 divided by 20.6678. Now I'm going to keep a bunch of decimals only because I'm going to have to use these again to work towards my final answer. Okay, so we're not done, but we're well on our way. Okay, so let's look at this triangle right here in the middle, and I'll highlight that one in red. Okay, so we now know this side here, it's that 20.6678, and we know this. Now yes, we can use trig to find out this angle, but we don't need to do that. Because this is a right triangle, it's probably a good idea to determine this hypotenuse, and for that we can use Pythagoras, because remember, a squared plus b squared is equal to c squared, which means, I'll do it over here, 20.6678 squared plus 5 squared, that has to be y squared. Okay, so you can work all this stuff out as a crazy decimal if you want. Let's see what y squared works out to be, and let's see, running into trouble here. Press the wrong button, oops. Okay, you get y squared is about 452.159. So taking the square root to get y gives me approximately 21.264. Okay, so now I know this length here, the hypotenuse. So now we have to do one more step to find theta. So for the last triangle, I'm just going to change color here and color this one like this. All right. Okay, so we want to determine this angle. We know that the opposite is 5.7. The adjacent, well, that's the hypotenuse from the red triangle that we just found. That's the 21.264. Right? So if you want to find theta and you know the opposite and the adjacent, well, that requires the use of tangent. So the tan of theta is 5.7 divided by 21.264. So to work backwards to recover theta, I just take the inverse tangent of whatever this works out to be. Okay, so I'm going to do that. I actually still have this number on display in my calculator. I haven't even cleared it yet. And I do that, take the inverse tan. Make sure you work it out yourself. But at the end of the day, you get, oh, that's pretty close. Approximately 15.0 degrees. So there we are. There's our angle theta. Number 2 says use any of the 3 trig ratios, sine, cosine, or tangent, to solve for x and y. And you don't necessarily have to solve them in that order, but let's see what we have. So if I want to determine x, okay, I have this triangle right here. Okay, So x is clearly the hypotenuse of this blue one. And I have this base down here is 13.3. It would be nice if I knew this angle. Well, you know what? I actually do. Because remember that angles on a line have to add up to 180. So if this is 137, well, 180 minus 137, that's 43. Okay, so using simple geometry, we can deduce that this can't be anything other than 43 degrees. So if this is my theta, this is the adjacent, x is the hypotenuse. That requires cosine. So the cosine of 43 degrees is my adjacent divided by the hypotenuse, which is x. And just to speed up the algebra, okay, this is what you'd get if you were to isolate x step by step. And 13.3 divided by cos 43, and you get approximately 18.19. It didn't specify how to round, so I'll stop there. So that is my x. So that's half done. Now we see if we can find y. To find y, notice how it is the hypotenuse of this large right triangle here. Okay. It'd be nice if we could know this angle. Well, it turns out we do. Because with this thin triangle here on top, remember all three angles of any triangle have to add up to 180 degrees. So 180 minus 137 minus 8 gives us 35 degrees. Okay? We have no choice. This has to be 35 degrees. So that's helpful. What would really be nice is, we know this is 13.3. If we could determine this little length here, hence the whole thing, we could determine y. Okay, but there's actually another way. Why don't we determine this? See, that's x. I will call this, I don't want to call it y. I'll call it h for height. Okay, if I can determine what this height here is of the red, that would be the opposite of angle of the 35 degree angle, and then I can use the sine ratio to find y. All right, so how can we do that? Well, here's my blue. I see how we can do that. We can use the tangent ratio, okay, because the tangent of 43 degrees is h over 13.3. So I'll set that up here. Tan of 43 is equal to opposite divided by adjacent. Okay, so sometimes, you just have to slug through it and just solve things piece by piece. And you may find that there are other ways of getting to the same answer. You might not particularly like this way. I encourage you to find other ways if you can. Okay. All right. So 13.3 times the tan of 43 degrees gives me approximately 12.402. Okay. So we're not done, but I think we're home free. We can use this to help us find y. All right. So again, we're looking at this large red triangle. We now know that the opposite of angle 35 is, well, 12.402, and we're trying to find the hypotenuse. So opposite, hypotenuse, we have to use the sine ratio. So the sine of 35 degrees is the opposite, which is this number here. I kept a couple of decimals, okay, so that my answer wouldn't be too far off, over hypotenuse, which is y, and I'll do the quick switch. That means y is just 12.402 divided by whatever the sine of 35 degrees is. Let's take out our calculator and work that out. And I haven't even cleared this from my display. I still have the long decimal in my screen. 5 by sine 35, and I get approximately 21.62. Okay, there we go. There's y, and there's x. Good problem. Number 3, determine the length of x without using any trig ratios. express your answer as a fraction. It turns out this problem is simpler than you might think. I have a right triangle here, but it is actually part of this larger right triangle right here. And in fact, these two triangles are similar. Their angles are all the same, even though one triangle is slightly larger than the other. That means all sides are proportional. Okay, so what does that mean? I'll keep my color consistent. So the ratio of x to 7, because 7 is the corresponding side here, okay, that ratio has to be the same as 4, okay, to this length here of the red triangle, which total is 10. Okay, well, that's it. We have a nice simple proportion, and you can use cross multiplication as a simple trick if you know what you're doing. Okay, so we get 10x is equal to 28, and dividing both sides by 10, well, that's easy. The decimal just shifts. So remember, we don't want any fractions, so we don't want to write 2.8. We just want to reduce 28 over 10. Okay, that gives us 14 over 5. Okay, but that's the same as 2.8. Here, I'll just make a note here. X is 2.8. But we did answer the question the way it wanted. Okay.